Hello everyone, welcome to the video presentation of our course project of Engineering Exploration course. I'm Abdul from Team 11 I Division. We are a 4-member team. Under the guidance of Mrs. Rajeshwari ma'am, the course project assigned to us was a disc throwing machine. Now let us go further to see details of our project. In problem definition, we are designed to make a disc throwing machine, as Decathlon Hubli is introducing a new gaming arena which needs this machine as a part of various games. So after that, we provided with problem definition, we categorize the specifications and group them accordingly to their functionality, considering a function type tree design. Now after this, we clustered the parts accordingly for better understanding of the flow of our project. Here are the subsystems that we identified. Basically, we identified some important subsystems, that is, first the launching unit, second the loading unit, and third the aiming unit. Next phase is the generation of concepts, that in which we'll select the most optimal concept among the 4 that we have made. First is the pinhole mechanism for aiming. Second is the pan tilt servo mechanism. Third is the single conveyor belt system. And fourth is vertical double conveyor belt system. After considering all the parameters, we selected the second design to be the best among the 4. This is how we selected our best design. Now we have reached one of the most important parts of our video documentation, that is the virtual implementation. Virtual implementation plays a vital role in the functionality of our machine, as we can know the dimension as well as the subsystem 3D modeling before implementing it physically. So let us look deep into the 3D models of our subsystem. So as you can see, a machine after assembling will be looking like somewhat this. So first I'm going to introduce the subsystems of our machine. The first subsystem is the holding unit. As you can see, I have highlighted the first holding unit holds the disc here, which will mounted by a stepper motor underby, which is connected through a stick here, and in turn help the disc placed here to move from this holding part to this launching part. This stepper motor plays a very important role in the movement of the disc. Now, after the holding part, second part comes in the launching part. This launching hub consists of a wheel type shape which is mounted by a rubber surface to provide friction with the disc for launching it through this exit channel. Now the third phase comes the aiming unit, which consists of pan tilt servo system. This pan tilt servo system will be powered by Arduino Mega 2560, and under that pan tilt servo system, a servo motor is mounted to control the direction of this launching hub horizontally as well as vertically. This will help our disc to aim at a particular angle. So these were one of the 3 main important units. Third part, fourth part is the holding part. This holding plane will provide a base to all the subsystems and help them perform their function smoothly It consists of a two-level base, which is consists of a low base and 4 poles, as you can see. So this was the virtual diagram of a disc throwing machine. Now we will see the circuit connections for our entire system. It plays a vital role in the functionality of the machine. In our circuit connections, we have the following components: Arduino Mega 2560, DC motor, metal servo motor, LED, IR sensor for sensing the disc. Along with that, we have stepper motor and an external power supply to power the system. Next, we have the bill of material. That includes all the material and the circuit components that are necessary to make our project. Moving along, next we have flowchart or the Simulink model of the entire system. As you can see, this is the flowchart of our system, and our display output will look like this. Next, we move on to the motor sizing and the battery sizing of the entire system. We calculated net weight that these motors are going to bear. Using the data, we accordingly found out the torque and the power to run this motor. First we calculated for stepper motor, then for DC motor, and at last for servo motor. These are the functional specifications of our system. These helps us understand the data much more easier. Now we have reached one of the most important part of our video documentation, that is modeling and simulation. Here we are creating a Simulink model for our system and thereby running it to provide the output for it. So now I am going to explain modeling and simulation of disc throwing machine. As we can see now, this is the Simulink model of the disc throwing machine. The input pin we are using here is a pulse generator to generate pulse of required amplitude. We are using here pulse generator because we don't have Arduino kit to use digital pin as input. So we have named pulse generator as IRV, and the output data are the display function. Display the data running the Simulink model, and thereby A, B, C, D, E, F and A LED and angle are named as the output data of the display. So when I run this, as you can see, we are getting this type of output. So let us look deep into the chart of our system. First is going through the stepper motor part. As you can see, so we enter into chart. You can see in the state flow 1, stepper motor is used here. When the discs are kept in the holder need to put into the disc unit. So we can use stepper motor to load the disc into launching unit. During the loading of a disc in disc holder into disc launching unit, the stepper motor rotates stepwise to complete one revolution of stepper motor. After completing one revolution in 5 seconds, the stepper motor switches to off state, which is this state. Now, after this, after 5 seconds, stepper motor switches to on state, which indicates that after loading of this completely, it switches again to off state, and again after 5 seconds it switches to on state again, whereas further disks are being loaded which are kept in disk holder. Now in the state flow 2, which is the launching unit, when disks are loaded into the launching unit, the DC motor turns on immediately after 1 second, where launching of the disk takes place, and when launching of the disk takes place successfully and after 5 seconds, the DC motor switches to off state, which is this state. So this is the launching part. Now we'll introduce to one of the main part, that is the aiming part. So this is the aiming part of our subsystem. Here angle changing capability is considered. When the disks are loaded into the launching unit during the launching time, the disk which we are launching, it is used to launch with any particular angle we desire. So we use servo motor which is present in pan tilt servo system, which help in horizontal and vertical movement of the glass pane or the launch pad. Thereby it is shifted to a particular angle which is, and the table is being tilted by that angle. For example, here we are using a 30-degree angle, which means the glass plane is tilted by 30 degree, and after that it comes to its normal position, which is 0 degree. Then LED light glows after the completion of this all process, which is sensed by an IR sensor, and hence the LED glows, stating the completion of the process of one disk have been thrown. So this was the modeling of our system. At last, thank you for listening to our video documentation.